Okay, what's up guys? Today we're going to review solving two-step equations. So by now you should already see or know how to do a one-step equation. So here it says objective is to solve equations using two steps. There's an easy way and a hard way, but really it depends on the type of problem. So the hard way is to undo multiplication or division first. The easy way is to undo addition or subtraction first. So that's what we're going to focus on. So just an example, I'll show you what to do the hard way. The original problem was 3x plus 4 equals 16. The hard way is to undo division or multiplication first. So here you're seeing that the x is being multiplied by 3. So I'm going to undo that by dividing by 3. 3x over 3 plus 4 over 3 equals 16 over 3. So already you have some weird fractions. The 3 over 3, that's fine. It just becomes x. But this still is 4 thirds, and this is 16 thirds. So then you have to undo addition. So you have to subtract 4 thirds from both sides. There's going to be 12 over 3, and then that becomes x equals 4. So you ended up with the right answer, but the problem with that, so the problem is, depending on the type of problem, you might do this incorrectly. So let's pretend that the problem was 4x plus 4 equals 16, right? So the mistake would be doing this. If you're dividing by 4 on both sides, and okay, you're thinking, okay, this cancels, right? And so this is just x plus 4 equals 4. You subtract 4 from both sides, and x equals 0. But that's, of course, not the case, because if you plug in 0 back into the original equation, 4 times 0 plus 4 does not equal 16. That's going to be incorrect, because if you're dividing both sides by a number, it has to be the entire side. So we forgot about dividing this by 4. So it's not like you can't do it. It's just, one, it takes longer for most types of problems, and two, it's really easy to make a mistake. So that's why. All right, so let's do the easy way. What you should do is to undo addition or subtraction first. So what I'm going to do is subtract 4 from both sides, because you have to look at the variable is x, and you want to undo whatever's happening to x. So x is being multiplied by 3 and added by 4. So I'm going to undo the adding by 4. So 4 minus 4 is 0. I'm left with 3x on the left side, and 16 minus 4 is 12. Then now this is back to a one-step equation. So the one-step equation, you just undo whatever's happening to x. So 3 is being multiplied to x, so you divide both sides by 3. And then you can see that 3 over 3 is just 1. That cancels. So then you have x equals 4. And then you can check your answer on both of these by plugging in your answer back into the original equation. So 3 times x, we're saying x equals 4, plus 4, does that equal 16? So 12 plus 4, does that equal 16? 16 actually equals 16, so then you know that you did it correctly. So rules for transforming equations. The goal is to isolate the variable on one side of the equation. In case there's a variable on left and right, you want it to be only on one side. Always perform the same operation to both sides of the equation. That's the problem I kind of showed you the mistake. The entire operation on both sides of the equation, not just one side. And then to undo an operation, perform its opposite operation. So if it's adding, then you subtract. Subtract, you add. If it's multiplying, you divide. If it's divide, you multiply. And then it's easiest to undo addition or subtraction first. Yeah, there are some exceptions to that rule, but I don't think we're going to get into it with two-step equations. Okay, so at this time you can kind of pause the video and do these on your own on a separate sheet of paper. I guess that's long enough of a pause, so we'll do these one by one. Okay, so we're going to look at all of these, and we're going to try to undo addition or subtraction first. So we're seeing what's happening to x, and we're doing addition or subtraction first. So x is right here. It's being multiplied by 2 and subtracted by 5. So I'm going to undo that. I'm going to add 5 to both sides, because if you're looking at this x, it's being multiplied by 2 and subtracted by 5. So I'm going to undo subtracting by 5 and add 5 on both sides. So this part, -5 plus 5, that's just going to be 0. So on the left side of the equation, so if I make sure all the equations lined up. That left side is 2x. And then you have 19 plus 5 is 24. So I'm going to put an equal sign there. Okay, so I'm going to now divide both sides by 2 because x is being multiplied by 2. So I'm going to divide it. So here you have x, and then 24 divided by 2 is just going to be 12. I'm going to box my answer. And then of course you can check your answer by plugging it back in to the equation somewhere. So I'll do it off to the left side of here. So 2 times 12 minus 5, does that equal 19? Well, yes it does. It's going to be 24 minus 5. 19 equals 19. So you know you did it correctly. Okay, moving on to the next one. You're supposed to subtract 15 from both sides here. And then 15 minus 15 is 0. You're left with x over 3, or x divided by 3 on this side. And then you have negative 9. So you have negative 9 there. And to get x by itself, I'm going to multiply by 3 because x over 3 is the same as x divided by 3. So I'm going to multiply by 3 on both sides. My 3's are going to cancel. And this is x, and this is negative 27. And then I can check this by going up here. Maybe I'll do the checks in a different color. 15 plus negative 27 over 3. Does that equal 6? Negative 27 over 3 is negative 9. So 15 plus negative 9, does that equal 6? That's the same thing as saying 15 minus 9. So 15 minus 9 equals 6. So then you did the problem correctly. X equals negative 27. Okay, let me zoom in a little bit for some of these other ones. 8x plus 1 equals 25. So I'm going to subtract 1 on both sides. You have 8x here. This is equal to 24. Divide both sides by 8. And x equals 3. Okay, and then I'm kind of just doing this in my head. 8 times 3 is 24, plus 1 is 25. And then off over here, x over 5 minus 4 equals 3. So I'm going to add 4 to both sides of the equation. This is 7 on the right side, and I'm left with x over 5, which is the same as x divided by 5. So I'm going to multiply by 5 on both sides. So I'm going to be able to cancel these 5's, because this is like saying 5 over 1 times x over 5, so the 5's cancel. You end up with x equals 35. Okay, so if I check, 35 divided by 5 is 7. 7 minus 4 is 3. Okay. Okay, so now we're going to do some translating. 5 less than the quotient of x and 2 is 37. So showing this, we're going to look at 5 less than. So it says 5 less than. So whenever you see that, that's kind of like a backwards word. So 5 less than is going to be something minus 5. So if you have like, 5 less than something. So it's going to be less than the quotient of x and 2. So whenever you see the word quotient, that means divide. And where you see the word and, that's where the operator goes. So the division symbol is going to go here. And then is, that's the easy one, it's going to be equals. So that's why it looks like this. The quotient of x and 2 can be written as x divided by 2, or x over 2. 5 less than that. So whatever the quotient of x and 2 is, 5 subtracted from that. So then if we have this equation here, you're going to add 5 to both sides. We have x over 2 is equal to 42. And then now you have your one-step equation. You multiply both sides by 2. Cancel the 2's. And you have x equals 84. All right, so this is a kind of a more challenging problem. So another time you can kind of pause and try to see if you could figure this out. Find the area of the rectangle below if the perimeter is equal to 60 centimeters. That's another given. All right, so go ahead and pause, try it out, see if you can figure it out before resuming. Okay, so I'm going to write down what information I do know. So I'm going to say the perimeter here is 60 centimeters. So, all right, and it's also given that this side is 9 centimeters. Okay, that's cool. So this side is 9 centimeters. That means this side over here is also 9 centimeters. All right. And it says write a variable equation. So something we don't know. So we don't know this length right here, right? So we'll say that's x, or whatever variable you want. If that's x, that means this is also x. All right. So then you think about, well, what do you know about perimeter? Perimeter means you add up all the sides, right? You add up all the sides, and then it's asking for the area. So this is like a two-part question. So we have enough information here to actually find out what x is. So the perimeter means you add up all the sides. So you can do it one of two ways. You know that 2L plus 2W is equal to the perimeter. You could do that and fill it out, or you could just add up all the sides, like 9 plus 9 plus x equals p. We'll use the original one here. So we'll say 2 times the length is 9. 2 times, let's say, 9 plus 2 times the width, which is x. And then equals the perimeter, which is already given as 60. Okay? So now we can reduce this to figure it out. All right. So 2 times 9 is 18, plus 2 times x is just 2x, equals 60. All right, now this is a two-step equation. So we did the hard part. This is stuff we've been practicing already. So to solve for x, I'm going to undo addition first. So I'm going to subtract 18 from both sides. So 2x is going to be 42. And then divide both sides by 2. And x is going to equal 21. All right. So if you're rushing and like maybe this was a test, you're trying to get your homework done, you might box x equals 21 and then call it a day. So that's not exactly the case. So the length was 9. So the width is 21. So maybe it's confusing because I put w and then x, but the width is the same as x here. All right, so I can actually fill that out. So instead of x, I'm just going to say this is equal to 21. This is equal to 21 here. So the actual question is asking to find the area. All right, so we're almost there. So to find the area equals length times width for a rectangle. So we already given the length, which is 9, and we just found out the width, which is 21. Okay, so if you do that, you just multiply area equals 189, and then the units are going to be centimeters squared because it's talking about area. So in this blue shaded region right here, there are 189 little squares that are 1 by 1 centimeter each. So that is your final answer. Okay, so that's about it for solving two-step equations. This should have been review. A lot of it should have been review. And yeah, hopefully that helped. Okay, so this has been a review on solving two-step equations. So hopefully that helped, and I'll see you next time.